Hi, quarantined kids. Today we're doing a lab and science class, so I want to take a few minutes and explain it to you, okay? I'll keep it brief. Where is the greatest kinetic energy? So today we're going to talk about how energy is lost and gained. So where's the greatest kinetic energy in this system? So you can see here as potential energy decreases, kinetic energy increases, and the greatest amount of kinetic energy of movement is at D. So the lab today, you're going to click on the link and it should open a Google Doc for you. You're going to use the video and picture that I have in this slideshow to allow you to do the lab. So kinetic energy is the energy of motion. If an object is not moving, it has no kinetic energy. So gravitational potential energy is the energy of position. If you pick up an object and raise it higher, then you're doing work on it, and it gives it more potential energy. We understand that the law of conservation of energy says energy is not created or destroyed, it just changes form. So if we picked up a ball and did 100 joules of work on it, how much do we raise it? We raise this 100 joules by using 100 joules of energy. If we drop the ball, then it's going to fall back down to the floor, and it's going to use, again, 100 joules of energy when it hits the floor. So if this is 100 joules of energy, when I hit my desk, it's going to use 100 joules of energy. So it's just changing forms whenever we use energy. This is all assuming that there's no friction. So whenever you see a car going down the road, it's not using 100% of the work that the machine's putting into it because it's losing work because of the friction. So in today's lab, we're going to assume that potential energy is equal to kinetic energy because there's no friction. Okay, so mass potential energy equals kinetic energy. All right, so in today's lab, you need to refer back to this, that potential energy is mass times gravity times height is equal to kinetic energy, 1/2 the mass times the velocity squared. We're going to do a lot of math today, so grab your calculators, okay? That's what you're going to need for this lab. So the first step in the procedures is to take the mass of the golf ball, all right? So I took the golf ball and I put it on the scale for you. You see that right there, it's 45.7 grams. You're going to just put it into Google or you can convert that into kilograms, okay? That's the first step in your lab. Then you're going to find the gravitational potential energy if you lifted this 1 meter off the floor. So there's another calculation you need to do. Remember, potential energy equals mass. Now you know the mass, put it in kilograms, times the gravity, 9.8, times height, which is 1 meter. Figure out the potential energy. You would then figure out the kinetic energy. And you are going to then watch how it bounces back. I'm posting the video for the bounce back that I did for you on a separate link because the quality is really low whenever I post it in here. Okay, so the video that you're looking for is this QuickTime video of me, and I dropped the ball. Well, Sienna Mann's helped me out. Thanks, Sienna. And I slow-moed it. And the quality isn't great, so if you can't see, you want to stop it whenever it bounces back right there at the very height of the bounce, and you want to look right about 75 centimeters is where it bounced back to. That's all you really need to know for the lab. It bounces a few more times and you can see how the kinetic energy is changing. And you can kind of hear the kinetic energy changing forms too. Okay, so I will post that again so you can watch it. You want to pause it each time it bounces back. What else you need to know? You will do a ton of calculations. You're going to figure out the velocity of the first time it drops and then the velocity as the bounce back. So those are the two velocities you're going to figure out, and you're going to compare the two. How did the velocity change after the initial hit of the ball? You will then graph for me, and this is something you might want to print out if you can. Otherwise, you could just graph it on here. You're going to do the number of bounces versus the height of the ball and make me a graph. Remember, when you're doing a title, it's the effect of whatever the independent variable is on the dependent variable. And put your thinking cap back on to figure out what the independent and dependent variable is in this lab. There's a few follow-up questions. The follow-up questions are a little different this time. I had the follow-up questions, some multiple choice, and then true and false, and then there's some short answers. Okay, so that is what you're missing today. I know I went over that briefly. Go back and watch the video of the golf ball bouncing and see how the energy is changing form, all right? You have until Thursday to get this done for me, and hopefully that helps you out. If you are struggling, instead of sending me a Schoology message while I'm trying to teach, could you please just send me a Schoology message and say, hey, can we meet after school during your 2 to 3 o'clock time? And just tell me what time, like 2:15, that you want to meet. All right, guys, I hope this helps you. See you later. Bye-bye.